Okay, so on page 204, we're doing problem 329. We're going to do parts A, B, and D. I'm not really interested in drawing that graph of the line between birth and 10 weeks. We'll do that later. But I do want you to do A, B, and D because this is going to talk about how to interpret the slope, how to interpret the y-intercept, and it talks a little bit about extrapolation. Okay, so there's a couple of different ways that you can interpret the slope. I always start with like the rise, but it doesn't mean that's how you have to write it. So how did you guys write it? Let's see. Who has something for me? David.
As weight increases by 40 grams, time since birth increases by 1 week.
Perfect. What's another one? Matt.
The weight of grams will increase by 40 every 1 week.
Yes. So I'm just gonna, so for, let's see, for every 1 week increase in age, this is just the book. I don't usually say this. I always say, you know, for every week increase, I always say that, like, what do I usually say? As the weight increases by 40 grams, the year, you know, the age increases by 1 week or something like that. So for every 1 week increase in age, the rat will increase its weight.
You have to specify since birth
Um,
because with the way you wrote it now, you could do it like 5 years later.
I don't, for every 1 week increase in age, the rat will increase
Because
its,
that means from 5 years to 5 years and 1 week, it would still increase by 40.
yes, that's exactly what that slope means.
That rat.
Oh, okay. Well, because they specify that it's.
Yes, they do. But so, because now we're going to talk about it, right? So now that's what it's supposed to be. That's, you know, because that's why we're going to talk about, that's why we're going to talk about letter D, because that's when we're going to talk about why this equation only works for certain things. Okay, so this is A. This isn't necessarily how I would write it. I always write it as the rat increase, you know, as the rat's weight increases by 40 grams. So the age increases by 1 week. Or time increases by 1 week. That's what I would write. Okay, he's age, right? As their 1 week, they increase by 1 week because they're talking about weeks, right? They're not talking about years. That's why when we get to part D, it's so important. Because could you imagine in 5 years what this rat would look like?
Be like 23 pounds.
Yeah, it would be bigger than most cats. Yeah. Okay, so we need to talk about and interpret the y-intercept. So what's the y-intercept? What does that mean? Who can do that one for me? Lucas.
I said at 0 weeks, the weight is 100 grams.
Yep. At birth, right? So at birth, at 0 weeks, the rat weighs 100 grams. 100 grams is pretty big, right? Is it pretty big? No? Okay.
No American. We don't use grams.
Okay. So at birth, the rat will weigh 100 grams, right? That's what that means. Okay, now D. What we're gonna do for D is we're gonna convert 2 years into weeks because time is in weeks, correct? So we know that its weight equals 100 plus 40 times, and how many weeks are in 2 years? 104, right? I knew that. I was just testing you guys. It really was. So how much does this rat weigh after 2 years? So we know grams, right? Because this is in grams, correct? 4,260. And what did they say? How many pounds are in a?
454.
So we're going to convert this to pounds. So we're going to divide this by.
454.
Yeah.
Do we have to do that?
Well, it tells you to. It gives you an idea. So to help you assess the result, if you know grams, that's good. So did you get 9.3833?
Yeah.
Okay. So after 2 years, you would have a rat that weighed about 9 pounds. Yes, Jeffrey?
Do you always want rounding to 4 decimal places?
Yes, we always go to 4 decimal places. So the question is this a reliable result? No, it's not. Because so it went from 0 to 10 weeks, right? That's what this, our regression line was based on 10 weeks. Not 52 weeks, not 104 weeks. It was based on 10 weeks. So is this a reliable result? No. What is that called? When we try to predict outside the range of our data, what is that called? It is called extrapolation, and extrapolation is not reliable. Okay? Now, if we try to predict within the 10 weeks, we could probably get a good idea. But outside that 10 weeks, even maybe we could probably go to 11 and be okay. But at 104 weeks, we're not going to be okay. Like that is extrapolation really at its best, right? Hey, look, we're going to have a 9-pound rat in 2 years. So, okay. So you can put it for the 5th graders because it does say data on the IQ test scores and reading scores for a group of 5th grade children give the regression line. So the first thing that we want to do is that we're predicting reading scores from IQ. So that's the first thing that you need to know. What are we trying to predict? We're trying to predict a 5th grade's reading score, right, from their IQ test. So in this context of this problem, what does it mean? So what does the slope mean in context of this problem? Ethan.
Means that for every point in the child's IQ, they would receive 0.882 for the reading score.
Yeah, so their reading score should increase by, as their reading score increases by 0.8, is it 0.882? 2 8s and a 2. Their IQ score will increase by 1 point. Or you can put their IQ score will increase by 1. Right? So, as their IQ score increases by 1, their reading score will increase by 0.882. So you just have to make sure that the reading score and the IQ, those numbers are going correctly. Anybody have any questions? Yes.
So you just have to say it away so it's like for every point of the IQ.
Yes.
Okay.
Yeah, because that's what it is. So your explanatory variable will always, or the one that's on the. Are you kidding me right now? Okay.